All right, this is a video on families of functions in our unit in Algebra 2 that's studying functions and relations. So we'll look at an introduction first, and then we'll do a few solved examples. So in this introduction, I'm giving you an example of a parabola as a parent function, and we'll look at what the different sorts of transformations we could do for this parabola are. But then I hope you can see that we could do these sorts of transformations with any sort of parent function. So vertical translation is just going to simply be moving this function up or down. Okay, in the example I just showed you, we're moving it up. A horizontal translation would be moving it left or right. So let's move it left. Okay, and a horizontal reflection would be reflecting it in the horizontal dimension, okay? And this would be reflecting it across the y-axis, okay? So we're sort of reflecting it left and right here, okay? The thing to see, however, is if we have a parabola and we reflect it across the y-axis, it's not going to change. So a horizontal reflection is going to look the same because it has that symmetry. A vertical reflection, on the other hand, will reflect it down across the horizontal x-axis. A vertical stretch is going to stretch it in the vertical dimension, and it's going to appear skinnier, but you can also think of it as being stretched vertically, sort of pulled vertically like taffy. And a vertical compression is going to make our parabola appear flatter and wider. Okay, so that's a quick summary of the different possible transformations you could do to any parent function. I have a summary of parent functions here, and I'm not going to go in detail over every single one, but just kind of introduce them to you. Linear function should be familiar to you. The core parent function is just y equals x. Absolute value function, f of x equals the absolute value of x, has that classic V shape with a vertex. The parent function has the vertex at 0, 0. The quadratic function is the parabola we were just looking, y equals x squared, when we were just looking at. Again, it has that symmetry, classic U shape right there is a parabola. An exponential function is y equals, or f of x equals b to the x, and this is one we'll be getting at in this class for sure. What's interesting about this one is it has an asymptote, so that means that this graph, this function, will get closer and closer to, in this case, the x-axis, but never actually touch it. Okay, so it just gets infinitely close to that x-axis right there. A cubic function is closely related to a parabola, and in this case it has that pattern where it flattens out a little bit near the origin and then steepens again. Okay, so that's y equals x cubed. And lastly, a logarithmic function is related to an exponential function, and here it has an asymptote of the y-axis, so this function will get closer and closer to the y-axis as you go, as it sort of travels down. Okay, just a quick overview of some of our basic parent functions that we'll be able to modify, transform, etc. So let's actually do some transformations right now, and your textbook or your notes should give you some overview, some rules for how to do this. So we're just going to apply those rules, but definitely look at some other resources if you need the instructions on how to do this. Translate the function y equals 3x plus 1 vertically by -5. Translate means move. And so we are going to simply turn this into y equals 3x plus 1 plus a -5. Okay, that's going to shift this line down, and it's going to result in an equation of y equals 3x minus 4. Translate the function vertically by 4.5, same deal. We're just going to add a 4.5 on. And that's going to give us a new equation, y equals x cubed plus 4x squared plus 2.5. So this cubic function would have moved up by 4.5 units. A horizontal translation, horizontally by 6, that means we're moving it 6 to the right. and we're going to replace x with an x minus whatever the translation is. So this is going to turn into 3 times x minus 6 plus 1. One thing to keep in mind is we are translating this by a positive 6 to the right, so you can think of this as subtracting a positive 6. We always need to force there to be a subtraction symbol in there. So this is going to turn into y equals 3x minus 18 plus 1. So our final answer is going to be y equals 3x minus 17. I encourage you to check some of these on Desmos, graph the original, and then graph our transformed one, and confirm for yourself that the line was shifted to the right by 6. Translate this exponential function horizontally by -4. So we are going to replace the x with an x minus the transformation. 3 times 2 to the x minus a -4. Okay, so once again, we are forcing a subtraction in here, and we're subtracting whatever the transformation is. So that can simplify a little bit. Y equals 3 times 2 to the x plus 4. Okay, so that would be our new transformed equation for that function. Reflect the function across the y-axis, so it's a horizontal reflection. So what that means is x is going to turn into a negative x. So we replace all our x's with a negative x, and that essentially flips our function in the left-right dimension. So our new function is going to be a negative x quantity squared plus 3 times a negative x, and then minus 5. So a negative x squared is the same as x squared, but that 3 times negative x turns into a minus 3x. And that would be our solution right there. Reflect the function y equals -4x minus 5 across the x-axis. So we're reflecting in the vertical dimension, sort of an up-down reflection. And here, a really nice way to think about that is just y turns into a negative y. Okay, and then we can do some simplifying. So negative y equals -4x minus 5. Let's multiply both sides by -1. Y equals 4x plus 5. Okay, so that line was that just flipped reflected in the vertical dimension across the horizontal x-axis. Stretching and compressing. Vertically stretch the function by a factor of 3. We just multiply everything through by 3. So y equals 3 times -2x minus 4. So that's going to be a vertical stretch. And that's because this value, the 3, is larger than 1. Peeking ahead, we have this one down here where it's going to vertically compress. And that's going to compress because that value is less than 1. Okay, so we can distribute the 3 up here, -6x minus 12. Okay, so that line that we started with was sort of stretched vertically. Vertically compress this function, so we'll just multiply through by the compression factor, 0.25 times the absolute value of x plus 4. And we can distribute that 0.25. So y equals 0.25 times the absolute value of x, and then plus 1. 0.25 times 4 is plus 1. We can combine some transformations together as well. So for this first function, let's first reflect it across the y-axis and then translate or move it down by 4. So vertically by a -4. That means we're going in the downward direction. Okay, so let's first reflect it across the y-axis, which means we want x to be replaced with -x. Okay, so we'll do that step first. So y equals a -x quantity squared plus 3, which simplifies into y equals x squared plus 3. So that actually didn't change the equation at all. Okay, but then we translate vertically by -4, so we will subtract 4. So our final answer here is going to be y equals x squared plus, actually minus 1. Okay, so that parabola was flipped vertically and then moved down. And our last one here is a log function, and you haven't worked with log functions probably yet, but the same rules apply. We'll translate it horizontally by -3 and then vertically by 5. So let's do the horizontal transformation first. Y equals log base 2 of x minus a -3. And we can simplify that. Y equals log base 2 of x plus 3. Now let's do the second transformation. We just need to move it vertically by 5 units. So y equals log base 2 of x plus 3, and then with the plus 5 added on at the end. All right, nice, we got through it, and that's a good place to stop.